Fabius has been a consummate professional, as I mentioned. He's a security researcher through and through. His focus and passion is really trying to understand function protocols and components that are built into different things. He's found as of late a lot of focus on industrial control system components. We're going to see a lot of the the approach, methodology, rationale. This is going to prove to be a very interesting talk. It's a pleasure and an honor to be able to introduce a great friend and colleague in the industry, Fabius Watson. So I'll turn it over to you, Fabius. Thanks for being able to present here at OWASP Atlanta.
Thank you for inviting me, Tony. Can everyone hear me just fine? I'm not sure how to judge the quality of the audio.
Coming in loud and clear.
Yeah, if there's a problem, just let me know. I'll speak up or speak quieter.
You have to
I'm gonna mute myself.
I'm not. Yeah. You're right. Does that look good?
Yeah. No, you're unmuted.
It's on your computer.
My sound, okay, yeah.
Your sound on your computer, yeah.
There we go. All right, that's better. All right, so as Tony said, I'm Fabius. I'm gonna give a quick intro about myself, but I'm not gonna spend too much time on this. So I got my start in cybersecurity working at a company called Alert Logic, which did something similar to manage incident response. I did that for about 3.5 years. Then I found my way to Versprite. Excellent opportunity. Very grateful for the opportunity. Learned a lot and got my foot into the professional world of security research. I've been doing stuff as a hobby before then, but that was when I really made the full pivot to security research. After my time at Versprite, I joined AIG, an insurance company, as a red teamer. So I got experience with sort of penetrating networks, but in a more of a stealthy way, and deploying customized attacks and malware, finding 0 days. That was really fun. After my time at AIG, I joined a company called Randori on their R&D team. What we did was we did a 0 days security research and found vulnerabilities to weaponize for use for red teamers to use against various organizations to prove vulnerability in hardened environments, which kind of ties into this talk because, we'll get into that in a bit. Right now, I'm at IBM because Randori was acquired by IBM. The R&D team became the applied research team. And I'm also now spending time on X-Force's new offensive research team, which it spun up maybe a couple months ago. So keep an eye out for that and what we end up doing this year. I participated in PwnZone. For those of you who don't know, PwnZone is a international hacking competition where targets are determined by the 0 Day Initiative, which is a branch of Trend Micro. And hackers from around the world spend time finding 0 day vulnerabilities in these targets and demonstrating them live in front of an audience. I've participated in the IACS PwnZone competition in 2021, which was pretty much my first introduction to this field of industrial control systems and industrial automation control systems. I also competed in PwnZone Automotive, where we basically hacked car and car associated technologies. Me and a teammate hacked a car charger, something like if you have an EV car, you have the charger that you use to power it. We hacked one of those, and we hacked 2 of those actually. And also most recently I participated in Ireland, where we hacked some routers and some printers. So I spent a lot of time, and these have all been my free time outside of work. So I spent a lot of time looking at exploiting interesting targets. And IACS, as I'll get into in a bit, I saw that as interesting. I was inspired to start researching it more intently because I'm from Houston, Texas. And in Houston, there's a big oil and gas community. A lot of the jobs in Houston are oriented around oil and gas. And in that respect, a lot of the cybersecurity interest is in oil and gas environments, which are IACS environments. Here's a list of some certs I have. I don't know if any of those need to be renewed or not, but I got them at one point. And this is my Twitter handle if you guys want to follow me. So I'm gonna get right into it. Start off, what is IACS? So I'm sure most people have heard of ICS. I had, but I hadn't heard of IACS. And until I looked into how to defend ICS networks and ran into a specification that describes defending IACS networks. And from what I read, there's an overlap, and this is what is addressed in terms of cybersecurity primarily. And it refers to systems that automate and control industrial processes. ICS is just the network. It doesn't include the automation component. But when you're dealing with like factories or like oil and gas environments, there's a lot of automation involved, and that also needs to be protected. So it's a sort of a subset. So it includes SCADA, PLCs, which is programmable logic controllers, I believe, DCS, which is distributed control systems, and other field devices. And one big difference between IACS and IT networks is that it prioritizes safety and availability over pretty much over all else, because lack of availability means that you're losing money, or you may not have access to like critical systems, and lack of safety means that people get hurt. And IT environments, usually if something gets like compromised, no one's gonna die, but in IACS environments, that's a real possibility. So I mentioned this already, but ICS is a broader term, and IACS strictly is referring to ICS with the automation component. And in cybersecurity, ICS is referenced in this standard, which I'm going to talk a lot about, which is IEC 62443, which it's a collection of standards actually, or rather technical reports. There's like 12 of them, and I focused on just two. The first one, which defines a bunch of the terminology that's used in the rest of them. I'm not going to go into that today because that was really boring to read. And the one that I'm focusing on is 62443-3-1, which talks specifically about securing these environments, and that was of my primary interest. And so, speaking of IAC 62443-3-1 is a technical report designed to guide the selection and implementation of security measures for ICS. Basically, it tells you everything you need to know according to their interpretation of security when it was authored in order to secure these types of environments. And I have it here. I printed it out. It's not that long, but it's like 100 and some pages of just like dry specification material, which
Wow.
I don't recommend. I don't recommend most people just read it for fun. But if you're securing one of these types of environments, it may be helpful. But honestly, it may also not be, as you'll see as I get deeper into this talk, because there are a significant amount of gaps in the recommendations, and I think they can frankly do a better job. Let's see. So this specification is broken into clauses. There's I believe 5 clauses. There's 6 clauses, 5 through 10. And each clause defines a specific area of cybersecurity that the specification addresses. And here I list the different general ideas behind each clause. Some of them are shorter than others, and some of them are more general than others. Because this was authored in 2009, some of the recommendations, like the clauses in general, aren't very helpful because either the technology or recommendation has been deprecated, or the information is just it's just not relevant anymore. Even if it isn't necessarily deprecated, it's not as big of an issue because of how the general cyber threat model has changed over time. So here are the clauses listed. authentication, authorization, filtering, blocking, encryption was a big one, management, auditing, and measurement. The different control software or control system softwares that different control system devices may run, and then the physical security controls, which I'll touch on it, but I won't talk much about it because in terms of attacking IACS, I don't plan on doing anything physically. So yeah, if you're a red teamer, there may be a physical component to some of your engagements, so it may still be very relevant. And in real life, whenever like nation states are attacking each other, it becomes highly relevant because, as I'll discuss later, in order to get access to some of these things, you have to be on site. You can't just like log in, right? It's not going to be internet accessible. But that doesn't make them unattackable. It just makes them, it just adds the physical component. So each subsection for the clauses. So clauses are broken into subsections. So for instance, the authentication authorization technologies, it'll have a subsection for each technology that it recommends. And each one has these different headings. And what's interesting is that specifically to me was the known issues and weaknesses heading, because they make a recommendation and then also explicitly state the faults of that suggestion. And also the security vulnerabilities addressed section, because reading that will give you insight into what could be done given that the target environment doesn't implement this particular recommendation or a recommendation or something similar, something that addresses the same vulnerabilities. So it almost kind of gives you a list of what attacks are possible, what it tries to protect, and then also the weaknesses that this recommendation doesn't completely address. So yeah, I found that interesting. I use that sort of to guide my thoughts, but also mostly I use just my insight and experience to think about the recommendation holistically and where there may be lapses, specifically in terms of the time that's passed since this was authored. So as I mentioned, it was, so here I'm mentioning now the criticisms of the specification is that it was written in 2009. I initially found the 2009 version, but I didn't trust that it would be relevant because it was written in 2009. So I paid for a 2024 edition, and the number of changes were like less than 5%. So it was pretty much the same document. Yeah. That really upset me because the next criticism, it's not free. So this specification, we buy directly from IEC. There's another organization you can buy from as well. It's like, so I mentioned there's like 12 of them, and each one's like $300 or $400. It's crazy. I was able to find a copy through a Singaporean reseller who was licensed to sell the specification. They only charged me like $60. But even so, like, how can you expect someone who maybe wants to implement a secure environment, but doesn't have the guidance to do so? But it's also may not be a priority to maybe the organization to follow a specific recommendation. Like, expect them to pay for this whenever they're not even sure if it's exactly what they're looking for. Like, they give you like a 13-page like overview of the whole specification, like all of the sections, like all 12 or 13 of them. But it's not enough for you to really make a judgment call, especially given that after buying it, I read it and I'm like, this isn't great. Like, I wouldn't, if I were someone who wanted to actually use the specification, I would have hated to have paid for this and saw what I saw. So yeah, so these are my two primary criticisms of the specification. I like that it exists at all because there's many different types of environments and technologies that don't have any recommendations for cybersecurity. And in those cases, people just have to fend for themselves, and you end up with proprietary solutions and all kinds of fragmentation and like and standard and like different standards. All right, so about this talk, I'm going to evaluate each clause. As I mentioned before, I'm going to validate some of the vulnerabilities that they claim to address, and I'm also going to explore some of the known issues and weaknesses. And And yeah, and also I'm going to consider modern threats as applied to IACS because a lot of this stuff is really old. I'm sure you've heard that before, like, oh, IoT is old and like IACS is old. And it's true, but it's just the nature of the type of technology that it is. And that when this stuff is deployed, it's deployed to last for a long time without much like management interference because doing so is costly, not just financially, but in terms of time and resources. So they try to make it last. As a result, a lot of stuff has lasted and is still lasting, but in a state that has kind of surpassed its like security practicality. And then I'm also going to assume that most of the environments that I cover are following the specification, because if they don't, then there's other things that you can do, obviously. So I'm essentially judging the specification and not necessarily IACS environments as they could be or may be in practice. So let's get right in. So the first clause is authentication authorization technologies. Also, I have notes on my phone, so you may see me like peeking at this during while talking. It's because I couldn't squeeze everything I wanted to into these slides in order to make it like not too long for you guys. So there are things that may be interesting or relevant that aren't on the slide that I may want to mention. So keep that in mind. So first, the state of authentication IACS. The primary issue is that in many cases there is none. Like some of these protocols don't require authentication. They just require you to know that it's there. And that can be scary in some sense. At least at the time that this was written, most of the situation was mostly that. And this is how they define it in specification. Now there are some methods of encryption, and more so there's rather than encryption, they restrict access to the network traffic more intently, so they don't have to encrypt things, which I think is an interesting strategy. A lot of these devices, like PLCs and different like they call it IIoT, which is not Internet of Things. It's like industrial Internet of Things, which is interesting because a lot of these things aren't on the internet, they're just on the network, but they call it IIoT. They have a lot of shared credentials and hard-coded secrets. So there are default passwords, of course, there's always default passwords, but more importantly, when you have hard-coded secrets or shared credentials, which is very common, more common than default passwords, because if someone gets access to the device that you have deployed, and they're able to extract the key, a shared key or credential that isn't configured by the administrator, but is embedded by the vendor, then that can be reused across all customers that have used this device. And I've seen that too many times. And oftentimes when you report it, the vendor doesn't want to change it because they rely on it. It's essentially a backdoor, but like for benign purposes, and they don't want to change it because losing their backdoor means they're unable to manage these things. But yeah, the other thing is like there's a lot of unencrypted traffic. So if these things are used, sometimes you can, if you have a man-in-the-middle perspective, you can sniff these credentials and replay them. The other thing is like multi-factor authentication isn't really a thing in IACS environments. It can be in if you have like, for instance, a Windows host, like they have something called HMIs, which are human machine interfaces, which are basically usually Windows computers that allow you to talk to the IACS devices, either via some vendor specific application or some web that is being hosted. And those may be configured with MFA, but the devices themselves typically don't have multi-factor authentication support. As I mentioned before, a lot of times they don't have any authentication support. So what's often used in IACS environments is role-based access control. This is preferred specifically because in these environments, you want to have access defined by function. primarily for the sake of for accessibility. So if someone's not there, but you need to get into a room, right? Because let's say some system is like out of control, is gonna blow up, hypothetically, and someone's like locked out of their account. Well, you don't want it to be configured in a way where only this person and this person has access. So oftentimes they configure based on a role-based control. So it's like operators can access this, and like supervisors can access this. And you see that a lot. Also, like I've looked at the like reverse engineering different ICS devices, like hard-coded roles, like a supervisor, operator, technician, and then like admin oftentimes isn't even like the most privileged role. It's rare to see like admin being the most privileged role. It's usually what it should be, right? The person who administers it, but not the person who like configures the deeper aspects of it. And then you have user usually, and then sometimes guest, which is questionable. But yeah, so role-based access control is what I've seen to be most popular, and also what the specification mentions is recommended. And this is in cases where there is access control. But I find it to be useful as a oracle for targeted attacks against users, because if you know that operators have access, and then these users have like operator levels of access, then you can pinpoint like phishing or brute forcing against those users, versus like I guess the Active Directory is also role-based. It's a little more complex than that. But in situations where it isn't as clear, it's trickier to determine like who to target. So that's something that can be helpful. And the other thing is that some of these solutions, if it's not embedded into the system, if it's a third-party role-based access control system, they're running software too, and software can be hacked. So like, for instance, I've seen in practice, Jamf, which is used for like Macs, I believe, and also Centrify, which is used for Windows and Linux, on like different assessments, targets like 0 days targeting these services that basically give them access to everything, which is similar to what's seen with Active Directory all the time, where a red teamer wants to get domain admin, and they use that in order to compromise the whole network. Well, these role-based access control solutions can be attacked similarly in order to compromise entire IACS networks, even though they may not be using something like Windows or Linux. I think I'm going kind of slow. I need to speed it up. Okay, so common oversights that I've noticed is I mentioned unencrypted passwords. They can be intercepted, lack of support for MFA, and then unchanged default passwords. The recommendations are: 1, change in default passwords. And the specification, what's interesting is that it actually mentions using a shared file for keeping track of passwords, as though that's like the suggested solution. And I thought that was reasonable given that this was written in 2009, but also interesting that in 2024, they couldn't make the simple change of saying, hey, use a password manager, because that's what people are using nowadays. But recommendation would be using a password management vault rather than share password file. And then also, where available, use a challenge and response or certificate certificate-based auth rather than credential-based auth, which I've seen in more modern IoT devices. IoT gets a bad rap for being weak, but it's been getting better over time. And a lot of these devices that you think may be like garbage devices are incorporating some things like challenge response authentication. All right, so next I'm going to talk about filtering, blocking, and access control technologies, specifically about firewalls. So firewalls in IACS environments are pretty much the same thing as firewalls in IT environments. The only difference being the kinds of rules that you set for these environments. Specifically, the way that IACS environments are configured is you have something called conduits, which they call them conduits, but they're designed for traffic to be one way. So traffic should be able to go out, but never in if a conduit's set up. That way you limit the attack surface without restricting your ability to transmit data. And the firewalls are responsible for, or firewalls or also other network configuration devices are responsible for ensuring that this configuration is set up appropriately. And in the specification, they have they want you to have a dual firewall DMZ. So you have your IT network, and then you have this DMZ, and then you have your OT network. And so the OT network is never supposed to be exposed to the internet. The only way it can ever reach the internet should be through the IT network, and that traffic should be transmitted through a conduit. Now, of course, there are situations in which the DMZ is able to talk to something inside the OT network and is also able to talk to something inside the IT network. And these are the things that you usually want to target whenever you want to penetrate from IT to OT, because if you're attacking an IACS network, that's your objective, essentially. You exploit the IT network, you have access to that, and then you pivot to the OT network, but that's not as direct as just sending packets, right? You have to find some bastion that has more access than you have from the IT network. So yeah, I would say that simple deterministic rules are preferred over like next-gen firewalls, because I don't know if you guys have followed cybersecurity news, but these things get hacked all the time. So the thing that you want to protect access to your network is going to be the thing that gets exploited to gain access to your network. And we've seen that a lot in the IT, like the WAN side of things, but they similarly can affect the OT side of things, OT firewalls. What I've seen is that there's a lot of overlap between vendors. So for instance, Fortinet, who makes the FortiGate firewall that gets hacked like every month. They also have like, I think they call it like Fortinet Rugged or something. And I think it's the same thing, but just like physically rugged. I think it's the same code. So one thing I ran into was I initially wanted to buy some of these things on eBay, but the problem is that they're really hard to find secondhand. Not impossible, but to find like a modern version of one of these like network devices was really tricky. And that leads me to believe that they haven't been audited as heavily as some of the IT alternatives. So that's something to keep in mind whenever, if you're deploying a network like this, is that a lot of stuff hasn't been looked at by researchers simply because of the difficulty in accessing the technology, not because they're necessarily like hardened. Also, because yes, because you don't have direct access to these things all the time. Sometimes they're in like really restrictive environments, like physically. You may not be patching them as frequently, right? So if you have like a Fortinet bug, I keep picking on them, but if you have a Fortinet bug and you exploit an IT environment, and it also affects an OT environment, well, the IT department may patch this within a week, but the OT department, it may take them like a month or two to get around to it, or even get someone out there who knows what they're doing, like fly them out to like, let's say an oil rig to like patch this thing. So that leaves you available to attack. So I mentioned briefly conduits. So they also have the idea of zoning where or systems that are like each other should be zoned together. And that's essentially its own like subnet, and it should not be able to talk to any other thing, similar to IT, but they just call them zones. I don't know why they made their own terminology. And then they have the conduits, which restrict like exposure. And yeah, so if you define zones broadly, let's say you're lazy architect for an OT environment. You just say, you know what, let's all put it all in one zone. Well, now, if let's say your data historian, which is a IACS type of appliance, gets hacked and like the DMZ, and it's supposed to only talk to group A, but all the groups are mixed together, you like group A's compromise results in the compromise of the whole network. And yeah, you don't you typically don't want that. So explicit zoning is recommended. I agree with that recommendation. The only thing that I have a problem with is like what I mentioned before is that the technologies that you use to separate these zones is also a target. And if that gets targeted and you're using that all over, then it becomes a crutch. And I really think maybe I'll do more research into this in the future, but I think that's an avenue for compromising these networks that hasn't been heavily explored. The last thing is that non-IP or proprietary protocols, which there's a lot of them. There's Modbus, which is there's Modbus, but there's also Modbus over TCP. And there's like Fieldbus and ProfINet and tons of other protocols that a lot of people don't use anymore, but are still used in practice. They rely on you to they rely on, like I mentioned, the unidirectional traffic. Some of them require unidirectional, some of them require bidirectional. And sometimes you just can't control the traffic because it needs the bidirectional traffic, and you just have to accept that that's a risk. Luckily, a lot of this stuff is really simple. So the implementations shouldn't be easy to mess up, but you can't really rely on that for security. And yes, exposure of network infrastructure. I mentioned DMZ services. This is probably the optimal way, I would say, to penetrate into the OT network, which is probably, like I mentioned, the primary goal. Of course, after you penetrate in, you want to compromise the stuff inside, but first you have to get in, right? So the historian server, which like it keeps like track of the status of different ICS systems over time and lets you reference it to like see a history of things. But yeah, patch servers, remote access servers, which are big because that's how your administrators get into the OT network. They can, like, if they want to administer the historian, they can access its web interface. But if they want to actually like directly talk to devices, there will be like jump servers or something. And those are obviously going to be remotely accessible. And then time sync servers, they're all attractive footholds because this is basically the limit of the attack surface. That's the only way you can really hit the network from the outside, but the outside not being the internet, just the IT network. I know I'm being redundant, but yeah. And then also insecure management interfaces. So a lot of these devices just have management interfaces accessible on the DMZ because they see it as like the DMZ is internal, right? Even though the DMZ isn't internal from the scope of OT, just like psychologically, you think, oh, this isn't on the internet, it's internal. And so they'll make the management interfaces for different devices accessible on the DMZ. So that's something to look for. And then also SNMP, which is oftentimes forgotten about, can be significant risk because it allows, if you like can guess a community string or if there's no password and there's no password, or if you can guess the password too. But if you can at least guess the community string, and sometimes in the documents for a device, it'll tell you the default community string for SNMP, then you can configure the device without any authentication. No, the community string is not always public. So public is usually the default community string for many devices, but it's not always. And here's just a list of different services that may be on the DMZ. There's a lot of different services that can be on the DMZ, and they present lots of different attack surface. Like I mentioned, the data dials themselves, which are used to create like the conduits, can be targeted as well. Replication services, patch management. So there's a significant attack surface, but remember, this is the DMZ. This doesn't get you direct access to the OT network, but this gives you access to something that has more access to the OT network than you had before. So it may be used potentially as a way to pivot into the OT network. All right, and then finally, network level attacks. Classical network level attacks work like ARP spoofing, VLAN hopping, specifically because these networks are designed in an older fashion. They don't use a lot of the more modern technologies for network traffic monitoring that IT networks use. They can, but in practice, you're more likely to be successful with ARP spoofing on one of these networks than you are on like a hardened IT network. And then of course, bidirectional DMZ traffic. So the DMZ can talk to the OT network and the IT network. And that enables sort of like a staging area for malware and also credential replay. And so the process network is also the control system and also IACS. They have so many names to describe pretty much the same thing, but it's not exactly the same thing. All right, so moving on. So encryption technologies and data validation. This is the next clause that I'm talking about. So brief description of what encryption is, what it does. So the standard mentions something interesting. It says that you may omit encryption if the environment is sufficiently like physically secure, meaning that if no one can get access to the target, then it's not necessarily required for you to have the best form of encryption, which I thought was really interesting. I guess if you have an air gap system, it makes sense that physical security can be seen as like a literal security mechanism for protecting the target from attackers. But I think, for instance, if you have this setup, right, physical security isn't easy to change. Like this is specifically talking about like walls and fences and like big gates and doors and locks and stuff. That's not so easy to change. So, but the devices may be easy to change. Patches may come in that changes the context of what this device can do. And if you're still relying on like the physical security, then it kind of leaves you open to attack whenever the situation changes without you being able to make significant changes without a re-architecture of your security deployment for this target. So I thought that was an interesting recommendation. And then also, I mentioned hard-coded keys before, but also cipher suites, right? So these devices have been in place for a while, maybe using a low bit ciphers for cryptography, where they are using cryptography. Like for instance, they may be using a 128-bit key, especially given that these devices may not be on most modern processors. And so a lot of them are on RTOSs, which are real-time operating systems, which means that they may not have the resources, because a lot of them, they may be on like an 8 or was it like a 16-bit chip that may not want to spend resources processing a key with 2048 bits, because it needs to run a more critical task on the RTOS to do something important. So that's something to keep in mind as well. And practical limitations, like public key infrastructure on a limited chip can be really resource intensive, and criticality is it has priority over security in these environments. So oftentimes that's not used. You'll see it asymmetric keys used, or if there is a public key infrastructure, it'll be low entropy. So the other thing is, I've seen this, the fallbacks. So if you need to log into a device and it normally has SSH, but SSH isn't there, well, oftentimes it'll fall back to Telnet. And I've seen this way too much. Like Telnet on these IoT devices is so common. And I'm sure you know the weaknesses of Telnet. One, it's not encrypted. It can be intercepted. In addition to that, it oftentimes reveals information about the device that may not be gained any other way. Like you hit it on port 23 and it just tells you, oh, I'm this device, this version, here's my login screen. And it's, yeah, so, and SSH sometimes it does that too, but it's encrypted and it's more secure. The other thing is the HTTP fallback. Because reliability is so important, if HTTPS doesn't work, oftentimes there's going to be an HTTP fallback. And in the case, for instance, of an over-the-air update, if you're able to intercept the traffic and downgrade it, oftentimes it'll just accept that and install the old version. We actually hacked one of the ICS? No, one of the chargers at Ponzone using this kind of technique where we told it to use HTTP instead of HTTPS, and it just said, well, I got to do it somehow, and it chose to do it over HTTP. But yeah, this kind of like old school approach to cryptography has really come in IACS environments. Nowadays, it's still very common, but it's like they're improving, but they're not jumping ahead to where we are now. They're like incrementally improving. So you'll see stronger keys, and yeah, and you'll see stronger keys, and you'll see more SSH. But for instance, there's still a lot of password authentication, not a lot of SSH keys being used. And the places that have seen SSH keys being used has been explicitly for the vendor to use to log into your system whenever they want to do like technician stuff. So you can't even configure, or in this case, you couldn't even configure the key for yourself, but the vendor had access. So yeah, but this is improving. And I think the biggest point is that it's well-defined how to improve in cryptography, but on these devices, oftentimes you don't have control over improving the cryptography of the device. You have to wait for the vendor to implement it. Yeah, so strengthening cryptographic assurance, require TLS and IPsec. I mean, that's ideal, right? I don't think that's practical. In the specification, it mentions enabling SSL because TLS wasn't a thing yet. Not really. And also deprecate clear text traffic because I'll go into it later, there's intrusion detection and prevention systems that can be deployed on these networks. But the issue is that they're not really crafted for IACS environments. They're not tailor-made for this, so they may not recognize some of the proprietary protocols that exist on these networks. Introduce key rotation, and then also hardware security models. That's more so for the vendor. It's a recommendation because if you can offload cryptography to a different chip, which is what a hardware security module is, then you don't have to worry about improving the capacity of your high availability chip that you need. And then lastly, apply MFA and hardware tokens to remote access gateways, because if you are SSHing into these devices, ideally you would want to have multi-factor. Oftentimes you're not going to have that, but this is an ideal just based on my experience. Like, I'm thinking about the attacks that I would conduct against these devices and how I would stop me, and these things would stop me. But yeah, a lot of this stuff is hopeful, but we have to talk about it in order to even make our way there. So, all right. So the next section is management, auditing, measurement, monitoring, detection tools. These titles are straight from the specification, so that's why they're worded weirdly. These guys, I don't know, spec writers, they like to use weird grammar. So this section was actually really interesting to me, specifically because now in IT, EDR is really big, XDR, whatever. And in 2009, EDR was not a thing at all, really. And so reading this was interesting because seeing the difference between where we are now and what they thought was the best approach to securing, I guess, like the host level of the device was really fascinating. So without reliability or reliable telemetry, incident response is guesswork. And we know that. And if something is compromised, you don't have telemetry, you'll never know it's compromised. And you'd have to like stumble across it or notice it through like manual analysis, which on these networks, I can't imagine they have like a SOC like IT network has. So I think it would be a lot rarer than identifying a threat on an IT network. And a lot of these controllers and other devices, they don't have the ability to like send logs. Like now we also have SIM, right? And SOAR. And but these devices have host level logging. And what I've seen at the best is a syslog output. I've actually seen that a lot, syslog output, but it's been very limited. In fact, I found a vulnerability in the device, and or a series of them, and I had an attack chain, and I was tasked with writing telemetry detection rules for my attack chain. And I was like, okay, well, I understand the attack in detail. Surely I can write a refined detection rule. And so I enabled syslog logging, and it didn't really log any of the interesting things that I was doing. So the best rule I could come up with would have flagged on tons of false positives. And I was like, this is silly, because like as the attacker, the exploit developer, and I have like SOC experience, right? I can write a detection rule, but I couldn't write one that worked with this target. And yeah, this was as part of the applied research team on X-Force at IBM. And we really struggled with finding an example where we could write a detection rule for one of our attacks, because we focused not on IACS specifically, but on a lot of IoT devices. And they just don't have good log telemetry outbound. So that's something that affects both IT and IACS. And then also I mentioned many times that non-IP-based traffic doesn't get a lot of IDS coverage. They focus on TCP/IP, some other protocols like ICMP, sometimes SCTP, but some of the more proprietary protocols, they kind of glaze over and don't really address at all. So the other thing is the malware threat landscape. Yeah, it's really bad. Yeah, so the malware threat landscape, there's references to like floppy disk viruses, and they're talking about like, oh, someone's gonna put in a floppy disk and they're gonna like cover your screen with like owned by acid burn. And it's like, they're not aware in 2009 of like the level of threats that we're facing now that are a lot more serious, a lot more refined. They have like teams of like 100 very skilled hackers, developers, etc., that are trying to compromise these things. And like the nation state level malware is not really addressed at all in terms of what they mention virus detection systems. And they're talking about like signature based stuff that we had like, what was it, 15 years ago. And it's not really like how EDRs identify actions and chain them together into detection rules. And so they pretty much don't have any recommendation for these kinds of attacks. And in addition, these devices don't have the means to install like EDR. I mean, it's similar to what we see in IT edge devices, in that they get compromised, but there's no EDR for these devices, not yet. And the compromises, they go without notice and for a long time. And like with Stuxnet, I believe it was like a logic bomb where it waited a period of time before it actually triggered. And I don't think there's no recommendation here, and I can't think of anything right now that could be done to really prevent that. Updates are also a threat vector. When you go to update these devices that are air gapped, you're going to use like a flash drive or I don't know, maybe a floppy disk, I don't know, to update these devices. And that's not always secure, because one, if you have an insider threat, which I'll get into towards the end, they may be able to use the premise of an update as a pretext for infecting the device, which I believe there's a technician that carried out the Stuxnet attack via flash drive. I don't remember the exact details, but yeah, and then also it's kind of like can't win, because moving away from the proprietary stacks also creates a shared risk of exploitability. So if you go from tons of proprietary protocols and go to just one unified protocol, then you just focus on attacking that, and that'll affect everything. So malware really kind of has a free-for-all in IACS networks. And I tried to think of a way, like a recommendation for preventing that. And aside from the vendor making significant changes to the design of their devices and their products, I don't see a way around it. Like particularly like in RTOS, for instance, in a real-time operating system, the way to infect it with malware is to exploit it usually with a memory corruption vulnerability. in a way that doesn't crash the system, and then add a task, and tasks are like processes in a real-time operating systems. You got a task that's essentially your malware. You do that, the chances of anyone ever finding that is like almost zero, because they would have to, one, have a similar exploit if the device doesn't have a means of getting that information. In addition to that, the uptime is critical for these devices. So you may have a memory-only implant that lasts for years. So yeah, that's the threat landscape of IACS. It's really ripe, and it's been being attacked for a while. I've talked to a lot of people who worked in places that have written stuff for specifically for IACS devices, and it's scary what they're doing. Like, yeah, can't talk much about that, but it's really scary stuff. I mentioned earlier endpoint protection constraints. These things can't run endpoint protection software. Some of them have like integrity checks, but after boot time, that's done. So if you hack it after boot time, then you can compromise the device. And then I mentioned here, network-centric monitoring is more common and more practical realistically. And also, do we want EDR and IACS? Like, if availability is a top priority, do we want like a CrowdStrike situation on our like oil rigs and our nuclear plants? Like, I don't really think so. Like, I'm sure some of them were affected on the like human machine interface and like server level, but not on the actual like PLC level. So. Let's see, what is this? I forgot to change the title on this one. So this is another section. This was about vulnerability scanning. So vulnerability scanning works in IT environments because we have huge awareness of IT environments. But in ICS environments, we don't really have like a collection of, I mean, they do exist, but they're very small. A collection of IACS specific vulnerabilities because they're not really, there's not a whole lot of them. They're not really accessible for research. The other primary thing I want to talk about vulnerability scanning is that when you scan a network, it mentions this in the specification too. When you scan these kind of networks with a vuln scanner, oftentimes you may just crash some of the stuff that's on the network because they're not robust and they're not meant to be scanned in this way, and the resources are limited. So you may just trigger a denial of service. And IT environments, denial of service vulnerabilities aren't really high value. And the CVSS scoring, they're usually really like lowly scored. But in ICS environments, I would suggest they are oftentimes critical level security risks because, or not necessarily security risks, they're a critical level risk because of the prioritization of uptime and accessibility and safety. So that's kind of a shift in like the scoring mechanism for threats in IACS. I think because of that, CVSS doesn't really feel appropriate in application to IACS targets. All right, so the next section is the control system computer software. There's basically just three different types of control system computer software. The server and workstation operating systems, which is typically going to be running like Windows or Linux. This is the kind of stuff that people are usually going to be working on. Then there's the real-time and embedded operating systems. This is what the actual like PLC and other IoT, I hate saying that, IoT devices are running, which you would typically access from a workstation over like Telnet or SSH, or there's some application that talks in like Modbus or something. And then there's the web servers and internet technologies, which is nowadays probably more common than what I just mentioned, which is there's a web server embedded in the device or adjacent to the device that allows you to manage and configure the device. So the server and workstation operating systems, as I mentioned, is going to be mostly Windows and Linux. Sometimes it'll be, you'll have Windows and Linux on the same network, and you'll have some other stuff on the same network from a workstation perspective, but it really depends on the device because sometimes they are very picky about how you manage the target, right? Yeah, I forgot what RTU was. But yeah, so controllers oftentimes are running real-time embedded operating systems. And as it mentions, not for the purpose of security, but because it's deterministic, it's fast, it's real-time, it's in the name. The servers are gonna oftentimes run Windows or Linux as well. The servers you're not usually gonna interface directly with whenever the environment is configured initially. The servers will be set up by the administrators, but the actual operators are gonna be using the HMIs. And access control is a higher risk in IACS environments. And what that means, well, it describes it. But yeah, what that means is that if you forget your password and you get locked out of a machine, that's way worse than if you're at an office on a laptop and you forget your password and you're locked out, because you're locked out of access to a critical system that's doing real world stuff with usually like potentially dangerous environment, then getting locked out can be a disaster. So oftentimes lockout rules are a little more relaxed, password policies are a little more relaxed. And as a result, as an attacker, you can take advantage of that and you'll have more leeway to conduct like brute force attacks or password stuffing attacks to access some of like these HMIs on the network. And then the specification never mentioned embedded Linux controllers. It only mentioned Windows and Unix, RTOS, and then the web stuff. But what I've seen is a lot of the RTOS systems have pivoted more towards embedded Linux. I think one, it's probably a lot easier to develop for them, and two, it's a lot more familiar for users. Also, the chips that are used in these devices have gotten a lot stronger. I know ARM has a series of like the Cortex M chip, which are smaller. We have the R and then the A, and the R specifically can handle a lot of. They can be as fast as some of these RTOSs were, even though they're running like embedded Linux. Let's see. So I talked a lot about RTOSs. I might skip this slide. There was one thing I wanted to mention about RTOSs again. So yeah, the limited resources mean that they don't have as much resources for security. Yeah, I think I'll skip this slide. I've talked too much about RTOSs.
Just quick question. So for the RTOS, back in the day, it was a Linux OS or a VxWorks. Is still the case?
Yeah,
Gotcha.
yeah. I see a lot of VxWorks. And what I saw recently, I'll mention this one thing. There was a device that was running VxWorks in its earlier version, and it was running and like it was a full RTOS image, and then in a newer version, like not of the same software, but like a new family that's based on the old version. All they did was they converted the RTOS into an L file and ran it in embedded Linux. So they really changed their code. They're still working on the same code base, but they're running it in Linux now. And that way they're able to add SSH server, they're able to add firewall rules, and it's more configurable without you rebuilding a whole system because they're still at the base of it using that RTOS code base, but as an L file, which is a Linux executable. That I thought was really interesting. So the last piece here is web servers and internet technology. So the specification mentions the ActiveX and Java applets. I think the way to administrate these things. I was thinking, wow, that's not how things are working these days. Installing those things are tricky now. But I thought two things about that. One, it kind of removes the client-side attack surface for HMIs that rely on ActiveX and Java access. But two, it may imply that some of these HMIs are still using ActiveX and Java applets. And that would imply that they're open to some attacks that may have been forgotten in modern times that are still applicable to a certain sector of operators. Yeah, so the historians I mentioned before, they have web servers. A lot of the things on the, pretty much, most of the things on the DMZ page, the list of services, they'll have web servers. And you can apply traditional web enumeration, web black box testing, web hacking techniques to attack these servers. I once tested a PDU, a power distribution unit, and I had physical access to it. And I couldn't get a shell because, I don't know, I'm bad at power hacking, I guess. But I tried to like glitch it to get a shell. I was worried I was gonna like shock myself because it was plugged into like a high powered like AC adapter. I like replaced my washing machine with this thing. And I was like, I don't want to glitch this and shock myself and like, or break the device because I didn't buy it, the company bought it. And so I was like, well, let me just take a look and see what's on there. I did a network scan with Nmap. I didn't really see, I saw SSH, I saw SNMP, and I saw some other stuff, but nothing promising. I saw the web server and I was like, well, let me take a look at this web server. It was my device, I bought it. So I logged in, but they don't just give you a shell from logging in. But I did like black box testing and I found an authenticated like command injection just from like, it was like you could upload a certificate, right? Or no, you could create a certificate and like, I assumed like intuitively, oh, it's probably just like running OpenSSL in the back end. And so I just put like backticks in the name of the certificate I want to create or something like that. And then I had to like ping back to me and so great. And I got a shell through a web interface and I'm like, these guys like, that's like, that's the kind of bug you don't see anymore that much, even in IoT, because it's been done so many times. And these devices, because I feel like because they don't have such a high volume of public vulnerabilities, they're more likely to have some of these low-hanging fruit vulnerabilities. So yeah, a lot of web hacking can apply to IACS devices. In addition to that, a lot of them have like guest authentication that's just informational. You can't change anything, but with the guest access, you can get a lot of information about the device. And that can be insightful as an attacker as well. For one of the pwn zones, we looked at the device that you go to the web page and like it gives you enough information for you to like the attack wasn't against the web page, but it relied on information that was unveiled in the web page. And without that, the attack wouldn't have worked. So I think that should be something that I don't know if it should change because operators may need that ease of access to critical information. Even without logging in, as I mentioned, accessibility is important, but it is definitely a risk to have that accessible. The other thing is where web access is required, should be restricted to DMZ. I've seen too many IACS devices on Shodan. And it's sad, like I mentioned, I'm not going over insecure network configurations right now, but I've seen them and they shouldn't exist. There shouldn't be any PLCs on Shodan. Hopefully they're all honeypots and no one's doing anything wrong. But yeah. Okay, so the last piece is physical security controls. As I mentioned, I'm not going to talk too deeply about this, but there are some things that I want to mention. So usually, whenever IACS is like heavily compromised, there's a physical aspect to it. Like when a nation state attacks someone's power plant or attacks someone's water supply, usually, hopefully, it's not because they were internet facing. Sometimes that has been the case, but ideally, they have to have some physical presence in order to deploy their attack. And yeah, significant breaches have often involved physical proximity, either of an outsider or an insider, or proximity via like network equipment over like near field technology such as Bluetooth or Wi-Fi. Also, I mentioned earlier, physical barriers can mitigate where security controls are absent. Because if you have this, you've seen like these power plants, they have these huge fences with barbed wire, water towers, like they're pretty secure. Okay, yeah, I'm doing good. I wasn't sure at all. But yeah, they're pretty locked down, they're pretty secure. So physical security is something that should be taken into account. I think me being a technical person, I assume you guys are more technical than like physical security oriented. I didn't really think of too many practical attacks against the physical security aspect because I don't attack physical security of like hardened industrial control environments, but. So the first thing is physical and proximity attack vectors. I mentioned flash drives before. That's been very effective in the past because it's not uncommon for you to use a flash drive in one of these environments if you're deploying an update or you have some patch or something. So yeah, it's not uncommon, which means that, like for instance, in IT environments, if you bring a flash drive into like let's say you work for the government, you're in like a secure room, you can't bring a flash drive or even your phone in because of the risk of stuff like this. But in IACS environments, it's more, there are situations in which it is acceptable. The other thing is like near field exploitation, Bluetooth. I don't know why. I had serial in here. I don't know why. Bluetooth, I mean, they have serial over, what is it? I recently saw serial over network protocol. Forgot where that was. Doesn't matter.
Well, these devices are starting to implement NFC as well, which is really interesting.
Yes, that's true. Yeah, one of the well, obviously, one of the charges I looked at has NFC for, and we didn't, but I believe one of the teams that competed found the vulnerability via NFC. So like, you put this charger, put it in your phone, and you compromise the charger. And then I didn't compete in automotive this year in January, but one of the teams, one of my friends, he competed, and he found a vulnerability that allowed you to. I thought it was cool just because of the attack vector, allowed you to hack a car via the charging thing. So like the malware is on the charger, and you plug it into the car and it hacks the car from that. So yeah, so just like the communication between devices in a way that's like non-TCP/IP should be definitely taken into account because there's a lot of oversight in terms of defending against physical and close proximity attack vectors. In addition, there are RF attacks that aren't even specific protocol, that aren't based on specific protocols. For instance, there's a hacker who bought one of those robot dogs from like Temu or China or whatever. And he found out that if he transmitted a signal at a certain frequency, the dog just died. It just shut down. And he posted it, and like in some news article, it's like, oh, he found a kill switch, hidden kill switch for robot attack dogs. It's like over sensationalized, but it was real, and it's something that I would have thought to look for. I wouldn't have just scanned through radio waves to see if this thing like turned off. Like, yeah. So even the oversight is on my part as a researcher because I usually look at Wi-Fi, Bluetooth. I found vulnerabilities and attacking things remotely over those protocols. But I rarely look at RF, like just raw RF. So that's another thing. Also, over these frequencies, you can oftentimes get outbound traffic. You can see what networks it's looking for. You can get information about different Bluetooth devices. Let's say you have like a drone that you fly across around an oil rig. They actually have really sick defenses against that, by the way, now. Like the oil rigs have like drone detection and shutdown, automated shutdown. It's cool. Yeah. But if they don't have that, you fly it around, you can get some of these IoT devices are placed, and you can get proximity of where they are, where they're located, what they're running, just by doing a sweep of like the airwaves, or not necessarily airwaves, but I guess, yeah, it's radio too, so airwaves. Last thing is improper disposal. If you do find one of these things on eBay, the chances of them having wiped the configuration data from the device is low because it's not like just some hard disk, right? It's a chip on the device. They may have, if they're proactive, flashed the firmware and reset it or whatever. But oftentimes they're just like gonna trash these things, or someone's gonna like take them and resell them online. And yeah, buying laptops and pulling out the hard drive and finding vulnerabilities, or not vulnerabilities, sorry, information about the company, way more common than buying IoT devices and pulling out the memory, like desoldering a chip and then putting it on a reader and then putting it in your computer and then reading the data from the chip. So that's something that people don't really consider at the present moment. And then I think it's the last slide, personnel insider risk. So human factors are always a a factor when it comes to security. They possess legitimate access and also context. There's been instances in IT, of course, of people being bribed for access to corporate networks, big companies. And I know for a fact that in terms of IACS, there's been instances where operators have been either bribed or planted by other companies into environments where they can deploy malware for a nation state. So yeah, so contractors oftentimes need privileged access, and then when they stop being contractors, the privileged access may not be revoked as quickly as they should be. In addition, contractors typically don't go through as much scrutiny for employment as full-time employees, or that may be overlooked. Like for instance, there may not be a full background check. If someone already has like a clearance, you may not redo a background check, right? So yeah, people are just something to look out for, and something also to abuse. Like there's improper training, specifically security training. Some of these operators aren't technical at all. They don't have security awareness, and so phishing them can be really easy. Or telling them, hey, go to work and plug this in, like, would probably even be more likely to work than if it was an IT professional. And of course, illicit marketplaces for diagrams, badges, or cover hardware, like the dark web, or just buying access to these environments. Like I mentioned, there's tons of them on Shodan. I'm sure there's people who have hacked the things that are on Shodan, and they're selling access to them. So that's another. So that's all. That's all I got. I was thorough. Like I mentioned, I had a lot more, but I didn't want to rattle you guys' ear off too much. If you have any questions.
This was great stuff. I mean, I was tuned in, locked in. There's a lot of stuff that Fabius put down is 1,000% true. A lot of great tidbits, and there's any one of the topics that he covered really could have been expanded upon for a given hour, but so many realities that you put forward. So Fabius, thank you for coming out and doing the talk with us this month in OWASP Atlanta. I appreciate you.
Well,
Open it up to questions online and in the room. Any question is legitimate, so please go ahead and ask. Super important. This is definitely I guess a niche area for a lot of the reasons that Fabius provided. I mean, a lot of the technologies, there's a lot of legacy tech, a lot of the security of the environment is actually really hard because you have limited capabilities of the environment to help for defense or reactive controls and things like that. But any questions, comments, this is the time to put it out there. So anybody online or in the room? Yep, go ahead.
So, say somebody wanted to start working in this niche area, what skills would they need to get? Like what paths would they need to go to?
I think a lot of the skills overlap with what the skills you would develop for IT, but I would focus on specifically OT design. Like this specification is a good start, but like I mentioned, it costs money. But there are places online where you can learn about the stuff in the specification for free. I was initially going to go that route, but I wanted to read it for myself, and I really used someone else's interpretation of it. And I mentioned this is just one of the reports. There's I think there's 4 sections, and then the first 3 sections are 6, and then the last one's 2 or 3, and each one's 100 pages. But it's also dated, as I mentioned. But there's public resources for learning specifically about OT security. So I would just start there. Also, I would look into I use AI a lot for learning new things. I would look into that, feeding it these documents so they're not reading 100 pages, just as a starting point. So yeah, that's what I would recommend.
Have you taken a look into SANS ICS 410?
I have. Well, I came across it in my research, but I didn't look into actually taking it.
Okay.
Yeah.
Yeah, I've taken a look into it quite a few times. It's something I could potentially take, but
Yeah. There you go. There's a SANS course. I forgot to mention, there are courses.
There's also a GIACS if you're.
Yeah.
Correctly. So
Yeah.
those are two things you could potentially take a look into. You got the money.
Yeah,
You
that's.
got the money.
Yeah, so I
that's-
didn't want to
that's the
recommend
big one.
anything that costs like money, because SANS is expensive, man.
Yeah.
Joe Grant do a phenomenal class on like IoT device hacking, hardware hacking wise. He's one person you can go to. Not sure how much he wants, like nowadays.
Joe?
Grant, yeah,
Joe Grant.
yeah,
Okay.
yeah. Have you ever, weird question, have you ever MRI'd or X-rayed a device?
No, I'm getting there. I'm just now getting
Okay.
into hardware hacking, more so this year.
Mhm.
I bought a bunch of books. I recently, like 3 weeks ago, I was in Austin, Texas. I took a course on fuzzing embedded devices, which was with emulation, which was really cool. Yeah, speaking of, the reason why I tuned into that course is because the instructor was someone that I participated in Ponto and ICS with in 2021. This guy was super skilled. He wrote an exploit for ICS protocol called DMP3 that attacks the protocol itself to get remote code execution to the DMP3 server. And all the other teams attempted to like do that and failed, but he achieved it. He also wrote another exploit for an HMI software that was a file-based exploit. It was a file-based memory heap overflow exploit. And what makes that amazing is that with file-based memory corruption, it's very tricky to like manipulate the heap in a way where you can take precise control over it, because it's not a scripting language like JavaScript is, for instance. But he was able to like embed objects in the file that cause the heap to be in a certain state, and then overflow a pointer and override a function pointer and call that to get remote code execution. So this guy was super skilled, so I was really excited to take his course, and it was a very valuable course. It was also expensive, but it was worth it.
Yeah, I'm just curious how like he ended, how did he know that the endpoint, how did it take the input and how did it digest it?
He reverse engineered the
Oh, gotcha,
the format, the file format.
gotcha.
And understood how the actual HMI application was parsing it and what objects it was creating as a result of seeing certain objects. And so he basically turned the file format into a script that allowed him to write
Interesting,
a
okay.
deterministic exploit.
Cool.
Can we, so I know that we're kind of running very close on time.
Yeah.
Can it be like this last question?
Oh, can I have to ask my question?
I do too, I'll answer fast.
Okay, two more questions.
Yeah.
Thank you.
So, my name is Emmanuel Garrison, right? I have an electrical engineering background,
Okay.
so I'm fascinated with anything about ICS.
Mhm.
But, career swings have swung me from network security, software developer, and yeah, so I never got a chance to go into ICS or OT. So even just a few months back, I attended a presentation on the security of our water supply systems.
Yeah.
Super vulnerable.
Mhm.
So I'm really fascinated with anything about OT. I try to, right?
And you're interested in how to get into it?
It's I don't know. I like what I'm doing now, right? So it's
Yeah.
like, but if there's an opportunity, I don't mind going to it at all. Now, you mentioned China,
Yeah.
and from your speech, you mentioned, from your presentation, from your slides, there's Ireland on there. You also mentioned Singapore. Like the host said, right, this is a very niche area.
Yeah.
China is a major exporter
Yes.
of machinery,
Yeah. Of everything.
industrial machinery.
Mhm.
Have you tested international control systems? I want to know.
Not from China, no. The issue, as I mentioned before, is getting them, right? They're expensive and oftentimes hard to source. Even if you have the money, sometimes you can't buy them because you're not like you're not in business with them. They don't know you. You're a random person, especially as an individual. So that makes it really hard to get access to test them. I would love to.
Okay.
There's tons of stuff I would love to test that I just can't get access to.
I mean, so if you wanna get like random individual one, it's easy to get it from AliExpress or
In-person
whatever.
people, we usually go
If you wanna
to-
get the actual
local.
manual ones,
Do you wanna
the
come
one
out
that
with us
actually
and
makes
continue
money,
this conversation?
is source control.
Okay, so
So
why
it's
don't we
gonna
do
be
that?
hard to
Cause
get a
the
good turnout.
security guard leaves at 8 and we have to clean up the food.
Yes.
But online, we had one question.
Yes.
How might a GRC analyst utilize this information to navigate a risk analyst? And or what kinds of job roles refer to the IEC 62-443 specifications?
So I'll answer the last one first, because that's the easiest. I think OT security architect or OT penetration tester would relate most closely to the specification. In terms of GRC, I think close to what he was saying, depending on where you source your technologies, not just from country, but also the vendors, that would determine, I feel like that would determine or make an influence on what you choose. Like your choice of architecture would be influenced by like different regional components. For instance, now the world is like, there's conflict in the Middle East, there's conflict in like Russia and Ukraine. And I think, that's a good point. I think looking at the stuff that Russia's attacking or Ukraine's attacking or Israel is attacking or whatever, will give you insight into what is being attacked, right? And so that may suggest that you may not want to use those particular vendors yourself because there's a higher risk for attack of those vendors.
It's a good point.
Yeah, I think it's just a matter of like maintaining insight into what different regions are focusing on in terms of attacks. And not only avoiding that, but being wary of that and monitoring for activity from that like direction and also accounting for their specific like strategies and techniques.
Okay, let's carry this to the local. Christy, if you want to come join us or anyone else on Zoom.
Thanks again, guys.
Be there.
Can I just ask a last question?
Go ahead.
Hey, so do you think there's an opportunity for like, taking like segmentation faults and just standard out in terms of errors on a particular like ICS, asset to be able to have some level of defensive, I don't know if you've gone through like a kill chain and then see like, okay, well, let me see if this trigger is like always a seg fault, or if I can just do like a standard out on something you can and see if that has more verbosity than some of the things that are feeding into, EDRs or SIMs and stuff like that, which is to your point, 100% like you can do an attack, it works, and then there's lack of data telemetry that helps the defenders, the SOC, to be able to defend. So what do you think if you were to basically like be given like a bag and say, hey, like go build something to do something reactive or defensive, like what would you be looking at?
I've actually thought about that a lot because I've been trying to think of a solution to the fact that there's no telemetry from these kinds of devices.
Right.
The issues that a lot of these devices, the RTOS, it's pretty much too tricky because each one's different. We can't really get a shell on them. They just run how they run. And
Right.
The Linux-based systems though are a lot more accessible for telemetry. In fact, when you're researching the devices, you need that telemetry to know what you're doing whenever you're like attacking it and debugging it. I think the debug information is pretty much synonymous to like the telemetry EDR we use. So yeah, it's possible, but you have to put your own tools on the device and they're
Right.
still resource constrained. So a lot of times your tools will disrupt the existing operations, which I think is one reason why EDR doesn't exist on these devices, because it's a heavy lift for these limited resource targets. But definitely possible. I don't think it's outside of the future of like maybe some company will be spun up and does this. Like maybe it scales back what it collects based on the resources available, et cetera. But yeah, I think more companies should put an effort into seeing which of their devices they can actually get practical telemetry from, even if it's manually scripting and writing their own stuff to get it out, especially whenever it's a focus point for attackers.
Yeah. Okay. Cool. Next time I'm in H-Town, I'll pick your brain more over dinner or lunch.
Sounds good.
Okay, thanks, guys. We'll see you next
Everybody.
time.
And